Good morning to all from the editorial board of Build Up portal. For the ones who are attending a Build Up webinar for the first time, welcome. For our returning audience, thank you for renovating your interest. Just a brief explanation of what is Build Up. Build Up is a collaborative platform in the field of energy efficiency in buildings. It is continuously updated and it represents one of the key sources of information on the topic of energy efficiency. You can register and become a member of the community, so you can upload news, events, present a case study, results from our projects, and so on. I would like to invite you to navigate the portal. In the Learn section, you will find all the podcasts of the past webinars, so it is possible to listen to all the previous presentations. At the end of this webinar, the link to the full presentations and the file to the PDF presentation will be made available in this section of the portal. It is a pleasure to host today's webinar in collaboration with H2020 Mobistyle project entitled Final Mobistyle Methodological Approach Session, which is the first session of the showcase of the final results of the project. Tomorrow, on the 23rd June, the second session will be broadcasted at 12 and will be entitled Final Mobistyle ICT Session. I would like to invite you all to contribute and participate in this webinar. You can ask questions by typing in the box on the right side of the screen. They will be answered at the end, after the presentations. Now, I would like to leave the floor to Anna Tisov, who will present the agenda and introduce the speakers. So please, Anna, we can start the session.
So thank you. So hello from my side. So as mentioned, I'm Anna Tisov, and I'm today here as Mobistyle project coordinator from the Huygens Engineers and Adviseurs from the Netherlands. And first, I would like to say thank you to the Build Up team for hosting this two-day webinar, where I'm happy that our project experts will share the main project's conclusions with you in the coming 2 days. So today, 1 hour and a half, and also tomorrow. So first, I will give you a brief, short recap of main project objectives and achievements. And this will be really briefly. And then I will give a word and floor to our experts coming from the different disciplines. So first of all, Dan Podiet, researcher from the Institute for Innovation and Development of University of Ljubljana and assistant professor at the University of Ljubljana, will speak about the new people-centered development style implemented in Mobistyle. And then after his 20-minute presentation, Cristina Becchio, assistant professor from Politecnico di Torino, will introduce the Mobistyle methodology on how to come from raw data to knowledge for different users that was integrated in our ICT solutions. And the last presentation will be by Professor Wouter van Marken-Lichtenbelt from Maastricht University, who will talk about the Mobistyle dynamic temperature profiles. And those sessions will be then followed by the Q&A sessions. So we will be happy to hear all your questions and answer those. And then, as mentioned already by the Build Up team, tomorrow is another Mobistyle webinar, which will be dedicated to presentation of the final Mobistyle ICT solutions, ICT tools, where you will learn on how this multidisciplinary methodology was integrated in our different tools, and also why actually we have so many different tools for user engagement. And of course, then this will also be followed by a Q&A session. So also, if you haven't registered for tomorrow's session, more than welcome to still register. So now briefly just a recap of what Mobistyle stands for. So Mobistyle had 5 pillars, so 5 main objectives, where the idea was that we want to present different users information on energy, indoor environment, and health, and in that way introduce behavioral change by motivating consumers and building occupants toward a more energy efficient, healthier building usage. And how we ensure this behavioral change and engagement by supporting users with easy to use ICT based tools that allowed data harmonization, or we gather the data from different equipment in the buildings and then translated this data into information that it's understandable to user, and in that way can lead to a prolonged change of consumers' habits. Yeah, of course, in the end, we were also looking into how can we penetrate with those solutions to the market, and in that way develop different people-centered business models, as also application for third-party developers. So as introduced, the Mobistyle required multidisciplinary approach in order to combine these aspects of energy, health, and indoor environment. And the consortium was therefore formed by different disciplines. As it will be presented by today's experts, we have different universities. Here we have the Politecnico di Torino, Maastricht University, Aalborg University, as also the Institute for Innovation and Development of the University of Ljubljana from Slovenia. We had the energy provider Tauron from Poland, who was basically the responsible for the Polish demonstration case. Then we had Whirlpool as a white goods supplier, and different ICT developers, high skills, Holonix, and demo consultants. And of course, us, Huygen, as the project coordinator, where we applied this Mobistyle approach into 5 different demonstration cases in different countries. In Italy, that was demonstration case provided by Politecnico di Torino, a hotel there. Then Aalborg University was responsible for the Danish demonstration case, which was a social housing in Kildeparken in Aalborg. Then Tauron provided the Polish demonstration case set, which was smart homes. Maastricht University, together with Huygen, was responsible for Dutch demonstration case, and the Ljubljana partners, so the Slovenian partners from the institute, engaged with the Slovenian demonstration case, which consisted of the faculty building of University of Ljubljana. So now just briefly giving you an overview of different objectives of Mobistyle. So as said, we had 5 main objectives of the project. So the first one was about providing understandable information on the aspect of energy in easy to handle and attractive way for different consumers, and how we did that. So the basis was this anthropological people-centered approach, which lead to identifying the basic needs of both of building as of building occupants. Then these needs were translated into setting up a behavioral action plan that for different cases that was integrated in the ICT tools, and all this will be also presented today. And in the end, those different action plans led to the development of different ICT solutions, which helped us to engage with building occupants in their daily activities at homes or in public buildings. And what we saw, so what we learned was that we had a lot of different needs. Of course, people vary, and therefore we had to tailor solutions for different building occupants. However, we also had to face the boundary conditions of both the buildings, of the sensory equipment, with the compatibility of existing systems, of new equipment that was installed in the building, as also we had some problems with the interoperability. The second objective was about personalized information, where we were combining aspect of energy, so the energy data with indoor environmental quality, with different daily habits, so taking into account different daily habits of occupants. And here we were looking for synergies between the energy and indoor environmental quality, and this has been implemented in all the cases. Where the case of looking into indoor environmental quality and health, this was specific objectives for the Dutch demonstration case, which will be also presented in the last presentation today. And what was one of the main lessons learned was that the ICT tools cannot be seen as standalone solutions, but they have to be really integrated in part of long-lasting awareness campaigns, so they don't end up to being just another app. Also, it was hard to find a correlation between certain indoor environmental quality parameters in a building and an individual's health. And this is also something that Wouter can tell a bit more later on. And also still what we learned is that practical economic return for energy efficiency can be sometimes still better incentive than just healthy indoor environmental quality. The third objective was about this prolonged change of people, and how can we achieve that by a modular services with giving information on those three aspects: energy, health, and lifestyle. And as mentioned, in Mobistyle, we developed different solutions targeting different building types as occupant types. And with that, we also had connected knowledge services targeting those different segments of user types. We developed different KPIs for different user types, and this is something that Christina will say a bit more. And also in our open platform, the modularity aspect was integrated by allowing this analysis of big data coming from the different areas of energy, indoor environment, and health for different Mobistyle users. And this will be presented tomorrow more in the ICT sessions. Also what was main lesson learned, that we can have different tailor-made package solutions. And in Mobistyle, we aimed to gather all the data at one single point, Mobistyle database. Again, we had some ICT challenges on how to collect this all data harmonization, interoperability, as also we would need much bigger data sets in order to really allow sufficient data correlation between the different data types, because our boundary condition was that we only had 5 demonstration cases. And then the fourth objective was about the new business model. So as I mentioned, we also focused a lot on exploitation and penetration to the market. Even though originally we thought to go out only with one single tool, Mobistyle platform, that will have integrated all the different ICT and user solutions, during the project duration, we saw that it would be much more easier to penetrate with different modules. So with the game, expert tool, dashboard, office app as open users platform, than with one single solution. And we also were challenged to understand really which business scenario would be more profitable and should be prioritized, since we only did the validation on a few buildings or a few cases. And then the last objective was really about our demonstration cases. So the fact that we wanted to achieve and demonstrate this behavior change in different real life environments, and in that way deploy and validate our developed solutions. And we did that. We had really different demonstration cases, as I already said in my introduction, and this led to the diverse Mobistyle campaigns. However, the challenge was, of course, on really achieving this behavioral change, because we know that behavioral change is a long-term process. And of course, in a research project, we were limited by resources, as also due to some ICT delays. Only in one case, we had a full year validation. So we believe that Mobistyle should really deserve to go on after the project duration in order to really see this behavior change, because we believe that it's like snowball effect, that it's going to be amplifying once people start understanding the impact of their daily behavior or energy use and health, and then we can achieve even greater impact. So with this in mind, I would like to close my introduction. But of course, if you want to know more about Mobistyle, about different aspects, you're more than welcome to visit our website, where a lot of information is available. We also have direct links to different webinars, as also you're welcome to ask questions today at the end. And I would like to give floor to Dan Podiet to talk about the people-centered approach within Mobistyle. Thank you.
thank you, Anna, for this presentation. And I just wanted to move on. So, as Anna already said at the beginning, I'm an anthropologist from Slovenia, and Jure Vetršek, who is the co-author of this paper, is an engineer. And I have to admit, it's a very interesting and fun experience to work with engineers, and I will tell at the end why. But we have to start here with this question, or this fact, that the buildings consume 40% of energy in the EU. So we started the Mobistyle project with this sentence, and the problem is it's wrong. So the buildings on their own don't consume anything, since people in buildings actually consume energy. So you cannot research only buildings or only people and understand consumption of energy. So this was our starting point in the Mobistyle project, and Anna already presented at the beginning objectives of the Mobistyle, and I will not read them again. I just wanted to emphasize that all those words or phrases in bold are actually about the people. So understandable information, behavioral change, easy to use, desirable, change of consumer habits, business models, future development, and so on. So I'm really glad that we managed to bring together different approaches, interdisciplinary methods to understand how people actually use energy in buildings. And we started the project with the 10 commandments. This is how we call them. And they come from the people and are intended for the people. So we started the project with focus groups, interviews, participant observation, and other methods coming from the side of anthropology, because we try to understand what kind of products or solutions do people actually want and need, and what can we design for them and with them. And here are just some examples. Here on your left side, you can see the calm technology commandment. So this one actually comes from a computer engineer, computer scientist, Mark Weiser, who is also the father of the so-called ubiquitous computing, and explained in 1980s that technologies should not be in the front of our lives and constantly in the front of our noses. Instead, they should recede in backgrounds of our lives and not constantly bother us with buzzing, beeping, push notifications, and so on. They should support us instead of bothering us. And this was one of the things that came out of these interviews, focus groups, that yes, people want to have solutions, IT solutions that would help them live a better life, but they don't want to be constantly bothered by them. Another commandment that came up quite early was the public dedication. So here on your right side, which explains that you can achieve much better results if people are really publicly dedicated to a certain goal. For example, if they swear, promise in public to others, yes, I will change my lifestyle, not just that they download an app and then forget about it. Or here at the bottom, you can see community maximum 150. And this is another rule which comes, and this one comes from anthropology. So it's 150 is the so-called Dunbar's number. It's called after an anthropologist, Robin Dunbar, who found out that cognitively people can live or understand communities up to 150 people. Everything beyond this number is somehow irrelevant for us or too vague to feel as a part of the community. So we used combination of these technological, anthropological commandments for developing of new solutions in Mobistyle, which are not only technological, but also non-technological. So the right combination seems to be very important. And here is a scheme that I have presented, I think, in every presentation in the Mobistyle project so far, and it's really important one. So the problem of the current development of new solutions, new services, is that it usually starts here in the middle with the interpretation and with the question of company management or of the designers or of marketing team. What and how will be created to serve people's needs, or usually they even call them users, customers, clients. So in my opinion, these are the words we should actually avoid and call people, people. And then they make the next step, testing, and do the so-called usability testing with the people. But actually the first two steps are completely left out. So the identification, who are we solving for and with? So we have to identify people and go to the people, analyze their needs, habits, what do they actually want in their everyday life. And then it goes back, the whole process. When we come back with a product or solution, we have to go back to the same people identified in the first step and go through the process once more or many times more to get a solution that will be useful, meaningful, and that will improve people's lives and not make it worse. So here once more these steps: identification, and here in the Mobistyle project, for example, we identified this university teacher who has become one of our heroes in the Slovenian case. So the teacher was ready to cooperate with the project because she felt really a need to show to others that you don't have to switch on the climate device, for example, to make your room cooler, or in winter you can put on a sweater instead of turning on heating. So these kind of things she presented to us, and she was also ready to be a part of a video that we shared around. And the voice of the people has proven to be really important, because people hear other people, not only the technologies. So the next step was analysis. We got information from different cases in different European countries, and then out of this came also this one of the 10 commandments of the calm technology principle, because we realized this is what people actually want and need. So calmer technologies. The next step was interpretation. We talked to people again and interpreted not only for them, but actually with them, what and how will be created to serve their needs. So here on your right bottom side, you can see one of the focus groups. So the faces of people due to GDPR are unfortunately blurred, but these are actual people who we talked with, and we tried to interact with them and try to find out which solutions they find most meaningful. And finally, we carried out testing with the same people that we identified in the step 1, and we asked them, how can we improve solutions to serve their needs? And at the end of the project, when we developed all kinds of solutions that will be presented later, we made new commandments for the future. We call them sustainability tips. And some of them are similar to those from the beginning. Some of them are different. And in our opinion, this is something that can be used beyond the Mobistyle project in other similar projects that combine health, energy, well-being, and the different approaches from different fields of science. And this is the interdisciplinarity, and combining different approaches is also, in my opinion, one of the most important results of this project. So here on your on the left side of this slide is Jure Veteršek, co-author of this presentation, and he didn't know that I will put him on one of the slides. And on the right side is Lös, so an engineer from Huygen company, which is the coordinator of the project. And why are these two people, for me especially, important? Because in my opinion, during this Mobistyle project, they managed to make a shift from the expert mindset to the more people-centered mindset. And they started using anthropological methods, interviews, focus groups, participant observation on their own, and shifted a little bit their own perspective. And this is also not only interdisciplinarity, but really the transdisciplinarity, which will be, in my opinion, in the core of Horizon Europe, which is the next scheme, financing scheme of the research and development projects of the European Union. So we have to go beyond just putting together anthropology, engineering, design, architecture, and so on. We have to start learning from each other. We have to start speaking the same language. And I don't just mean that we have to speak English. We have to start speaking the language which goes beyond anthropology, beyond engineering. And in this way, we have to create hybrid experts who will understand both sides, the side of social sciences and humanities and the side of engineering. And there is also the next step that we have to make in the future. So now, hopefully, in the Mobistyle project, we managed to make the move from the expert mindset to more people-centered mindset in development of new solutions. The next step that is urgent and it is waiting for us is to take into account all other beings, not just to put people in the focus. Here you can see the more egocentric perspective of the people-centered mindset. So we should also take into account other beings and the whole planet and try to understand which solutions are meaningful for the planet and how we can improve their life on Earth. Because in this way, we will not act only altruistically, it's actually also egoistic way of thinking. So if we take care of others, whoops, so I'm expressing my thoughts so loudly that I broke a plate meanwhile. And I just wanted to say that in this way, if we make a shift from the people to planet-centered mindset, it's also a way for all of us to survive on this planet. And this paradigm shift is really urgent and necessary. So this is it from my side. And if you have any questions how to implement the people-centered or planet-centered mindset in your projects or development of solutions, please ask now, or we can answer your questions at the end of our presentations. Thank you very much.
Okay, so good morning to all. I'm Cristina Vecchio. I'm a researcher and I work at Politecnico di Torino in energy fields and also in indoor environmental quality fields. In order to present the methodology that we use in Mobistyle project, I think that I start from the last point that Dan stressed to us. So that is one of the main features of the Mobistyle project is the multidisciplinary approach in this slide presented. In particular, different expertise are required in the project, in particular expertise in energy fields, in order to elaborate the relationship between energy use and occupant behavior, as well as the relation with the indoor environmental quality. Expertise in health science in order to establish the relation between energy and individually based thermophysiology and other health parameters. Expertise in social science, in particular anthropology, to deepen individual factors related to occupants' choices and their energy use and behavior in terms of indoor environment choices and health. And at the end, but not least, information and communication technologies represent another expertise in order to develop the ICT solution that are used in the project. This holistic approach is addressed to develop an effective methodology that combines together three main research areas: energy, indoor environmental quality, and health. To stimulate users to perform more conscious actions, a combination of data collection and then data analysis and elaboration and tailored information via feedback to the user should be provided. So these figures show the step of the methodology. So first, we have data collection to investigate the operation of users on energy system in buildings. Then we have data analysis and elaboration in order to depict and understand the human behavior, especially related to energy, comfort, and health, in order to obtain some performance indicator. And then finally, we have improvement in terms of energy saving and indoor environmental conditions, and also human health and well-being is achieved through behavioral communication strategies, so the so-called awareness campaign. So we have a new awareness. All of these steps are possible thanks to the development of new key performance indicators, so the so-called KPI, and also new ICT tools that are used in order to provide the information to the different users in the different demo case. So in this slide, we have the methodological framework in different steps. In particular, we have at the beginning the parameter definition, so which data should be collected in the different demo cases. The second step consists in raw data collection. So how should the data be collected? So in terms of sensors that must be installed in the different demo cases. That can be also wearable sensors, especially when we are analyzing health parameters. And also mobile application in order to have the data, to get data and to share this data with the users. The third step consists in data analysis. So what does the data tell to us? And so we have the elaboration of raw data. Thanks to the raw data, we have the fourth step, so KPI definition. How can the data help us to evaluate energy saving and comfort of the occupants in the different demo cases? At the end, we have the awareness campaign. So how can the KPI be easily understood by the occupants thanks to different mobile applications that are diverse in the different demo cases. So we have a dashboard, we have serious games, we have also stickers, so not mobile application, but stickers putting in the demo case. One of the core activity of Mobistyle project was the elaboration of the methodology that could translate monitoring raw data into knowledge for the user via feedback. Feedback which promotes healthy behavior, improve the lifestyle, indoor environmental quality, and energy efficiency. This is possible through the definition of meaningful KPI, meaningful for user, and also tailored behavioral action plans. In particular, the behavioral action plans that is here show, the behavioral action plan definition is based on the main drivers of behaviors according to the TPB theory, so the theory of planned behavior, so attitude, subjective norms, perceived behavior control. So behavioral change goals are defined, and then personalized short-term objectives are translated into actionable tasks to be performed by the user. So actionable means that there is a behavioral change. So in this way, data coming from the building, and in particular from sensors and from the users, are transformed into useful KPIs. These KPIs are translated for the users into meaningful and easy understandable information. At the same time, some variables calculating from monitored raw data are used to generate feedbacks to the user in terms of action that they have to do. So users are encouraged to improve their behavior, so to behave more consciously and to be proactive user of their buildings. So in order to have an example, here we have the behavioral action plans for the Italian case studies, because we have a different behavioral action plan for the different demo cases that we have in Mobistyle project. So in Italian case studies, we have information from sensors that are used in order to calculate the different KPIs in terms of energy, indoor environmental quality, and occupant behavior. These KPIs are used in order to provide the feedback to users, and these feedback are translated into action in order to obtain behavioral change objective. For example, the sensor is constituted by thermostat, so the KPI is represented by set point temperature. Feedback provision said to user that some thermostat adjustment is necessary. So the behavioral change objective in this case is improve indoor environmental quality and comfort of the occupant, but also energy savings in terms of heating and cooling. So the other core activity of Mobistyle was the definition of the evaluation strategy that is shown in this slide. The definition of the evaluation strategies consists into three main phases. So the outcome evaluation, the process evaluation, and the impact evaluation that represent the last step. So here we have the timeline of the project that is characterized by three different moments of monitoring M0, M1, that M0 represents the initial monitoring phase. And then after this, we have the benchmark definition, so the baseline definition in terms of parameter and in terms of KPIs. Then we have the second monitoring phase, in which we have a feedback provision. So at the end, we have an intermediate evaluation of the outcomes of the project. And then we have another monitoring phase, the M2, in which we have optimized the feedback provision. And at the end, we have the final evaluation. So the outcome evaluation assess the effectiveness of the awareness campaign, as described before. The final objective of the outcome evaluation is analyzing the energy saving obtained in the different Mobistyle demo cases and quantifying their environmental impacts. This consists in a comparative analysis of the specific KPIs that are defined in the benchmark moment, in the benchmark definition moment, the E1, to establish changes over time in terms of energy consumption, indoor environmental quality, health, and behavioral patterns of the occupants. In the other two evaluation phases, so the E2 and the E3. The process evaluation consists in evaluating the provided feedbacks in order to optimize them and in order to improve the implemented process. After that, we have impact evaluation that assess long-term changes in social, economic, and environmental conditions, as well as long-term maintenance of the desired behavior. So to assess the behavioral persistency, as you can see here in the modified timeline, an alternative evaluation strategy is defined, including an additional phase of monitoring, the M3, in which we have no feedback another final evaluation that represents the E4 after the interaction of the feedback provision. So this is interesting because we have the possibility to have diversified feedback or no feedback per different target group. And this means that we have the possibility to test the behavioral persistence of the behavioral change that we reach during the Mobistyle project. So unfortunately, due to the COVID-19 spread, it's not possible to develop this last phase of evaluation. So we ended with the evaluation E3 as a final evaluation, as shown in the timeline of the previous slide. In order to develop the evaluation in terms of feedback, different descriptive statistics are used in order to quantitatively describing the current performance of the different case studies in terms of energy, indoor environmental quality, health, and behavior. In order to assess the impact of the project, of a Mobistyle project, a cost-benefit analysis was developed. This is important because the assessment of human-centered intervention related to the use of energy consists in going behind the energy savings that is the objective of the project throughout the identification of all the market and non-market effects that the proposed ICT solution can generate. The cost-benefit analysis consists in this, so in defining, quantifying, and monetizing the impacts generated by the project. Thanks to the cost-benefit analysis applications, also co-benefits are included in the evaluation. So the co-benefits represents the benefits referred to the society. So this is very interesting. So the results of the cost-benefit analysis can highlight the opportunity and the effectiveness of ICT solution developed for the different demo cases. And moreover, the monetization make benefits tangible, motivating persistent behavioral changes. The method adopts an incremental approach. In particular, the cost-benefit analysis considers the difference between the cash flow in the with the project scenario and in the without the project scenario that represent the counterfactual scenario, the baseline that represents the reference. So starting from monitored data of two equally long and comparable periods in pre-Mobistyle and Mobistyle period, impacts are quantified and monetized in the two different scenarios in order to compute their differences. So depending on the sign of the differences, extra cost due to Mobistyle or benefits gained thanks to Mobistyle are defined. So at the end, we have the calculation of the net present value. This indicator is calculated in order to assess the economic benefit brought by the project and so the effectiveness of ICT tool that provided feedback to the users with the aim of changing in a persistent way their behavior. In particular, for different tailored cost-benefit analysis, tailored for the different demo cases, were developed. In particular, we have two layers of analysis. One that is the first layer that represents cost and benefits for occupant, owner, and employer perspective. The second layer represents the perspective of the society. So, for example, in this second, if in the first layer we have energy consumption that represents a cost or a benefit if we have a saving in comparing with the project scenario and without the project scenario. The second layer represents the society perspective, and so, for example, we have the calculation of greenhouse gas emission in order to understand if we have saving or not. So, in order to close this presentation, in this final slide, I try to summarize the main aim of the project. So, the persistent behavioral change in the user. We go from an automatic behavior to another kind of automatic behavior. In particular, on the horizontal line, we have time, and so we have a phase of unawareness in which the occupant may not be aware if their behavior may impact on energy consumption and indoor environmental quality, and also on their own well-being. So I don't know, I don't know. The second phase represents the phase of learning. So, with the help of the Mobistyle awareness campaign, the occupants learn about how their behavior affects building energy use, affects indoor environmental quality, and also their well-being. So, I know that I don't know. So we have the third phase, that is the habit formation. So the occupants start putting into practice the information they learned and may develop a change in routine habits. So I know that I know. At the end of the timeline, we have the internalization of behavior. So the occupants adopt and internalize the new and more conscious behavior and now act automatically. So I don't know that I know. So if we reach this last phase, we have a success in order to reach persistency of behavior change. So thank you.
Yes, hello. My name is Wouter van Marken-Lichtenbelt, and I'd like to present some of our data more linked to biology. I'm a biologist, and I will give some information that we found during this project, but I'll also introduce the ideas behind it. And I'm a biologist working in Maastricht, and I fully agree with Dan Podget about the collaboration with the engineers. So biology and engineering goes well together, as also is accomplished here in the Mobistyle project. So in the end, I would say biology, anthropology, engineers, and maybe also psychologists should join efforts to come up to a healthy and energy saving built environment. Okay, so let's see. It doesn't shift, does it? Now I'm back to, oh, it's a bit slow. Yes, here we are. So yeah, we should not forget that we evolved in more natural conditions and that we still are dependent from our environment. But one thing that we cope with in our thermal environment, with the temperature, around us, is by behavior. And one of the main things we achieved by behavior is build microclimates, build houses, the built environment. So of course, in the old houses, we still had contact with the environmental conditions, but as we made better and better buildings, we are more and more isolated from our natural conditions, and we are more and more getting into more or less strict, comfortable conditions without any variation anymore. And then if we face that we are more than 90% of our times indoors, this really may have health implications. In parallel with these changes and more fixed environmental conditions, we see also a huge increase of Western society. Sorry, there's something. Oh yeah, sorry, I want to add this. So here you see the change in comfort. Not so long ago, it was about, let's say in the 70s, it was normal to have room temperatures in the sleeping room, for instance, as for 15 degrees Celsius, and in the living room around 18 degrees Celsius. These are data from the UK. And you see nowadays, we are really used to have 21 degrees Celsius in all the rooms of our dwellings in general. So there's really a huge change. And this is then in wintertime, but in summertime, we're getting more and more fixed temperatures as well. And this has huge implications for the energy consumption in buildings. And here you see some of the expected growth in air conditioning. It's really something we should try to avoid. And one way to avoid this is to have more exposure to different temperatures. That's to say, to get into a dynamic environment. I come to that. Parallel to these changes in comfort conditions, we see a huge increase in the metabolic syndrome, which is really linked to our westernized society, our Western behavior. and comfort conditions. And that is not only, of course, of the temperature. Very important is our food intake and our physical activity. But anyway, it links to lots of metabolic diseases, from cardiovascular to diabetes, etc. So you can do something about that and try to avoid the overweight and related diseases by doing something about our energy balance. So we get energy inside the body, and I'm really talking about the energy of the human. So you can do something by eating less or expending more energy by having a higher amount of physical activity. And that energy balance is then linked to the weight balance. I think this is clear to everybody, but not so clear is that you can also do something about it by looking at your thermal environment and expend more energy by being outside of your thermal comfort zone. I'll come to that in a few slides. So we look now more and more at other lifestyle factors. Of course, the most important lifestyle factors are still food intake and, let's say, physical activity, but others like the ambient temperature is also an important one, we believe. So just 1 or 2 slides about the thermal physiology. I think that's important in order to understand that the human body has its own heat production. That's our metabolism. And of course, all that heat needs to also, you need also to get rid of that heat, otherwise you would get higher and higher core body temperature. So the heat balance is important to achieve 37 degrees Celsius in our body. Very important here is that we can have different means of regulation, and a cheap way to regulate our body temperature is by changes in the heat loss. So that we can do by more blood to the skin or less blood to the skin. So we change the blood perfusion, and that is for the body a cheap way. It does affect our metabolic system, so it is important. It has a cardiovascular challenge, so it's good to have some changes in perfusion, but it doesn't cost us extra energy, so our metabolism is not so much affected. On the other hand, you can also regulate your heat production, and that's the next slide. And this is maybe a bit complicated figure, but if you look at the green area that we call the thermal neutral zone, there we regulate by means of this perfusion in the body. But if you get in a cooler environment, let's have a look on the left side, then you see you can increase the energy expenditure by shivering. And we did a lot of research also on non-shivering, because non-shivering is more comfortable and still you expend more energy, your metabolic rate goes up, and that creates a more healthy body. So there are 2 ways to really affect your health in the body: by metabolism increasing and by changing the perfusion. So is comfort that good? Well, in natural circumstances, yes, of course. You had to save energy because there was not food available when we lived in the savannah in Africa. So we had to be safe on water and energy, and that comfort drives then our thermal behavior. But nowadays, in our modern society, everything is there. We don't need to have a lot of physical activity, and we're always in the same temperature. So now a slight discomfort may increase our metabolic rate again and get into more natural and healthy circumstances. And moreover, very important, I didn't stress that, is the resilience is also increased by being exposed to slight temperature changes. So acceptable temperature changes also creates more resilience to more extreme conditions like heat waves. So we did a lot of research in Maastricht. We have special metabolic chambers, climate chambers, where we can measure the human energy metabolic rate in great detail. So if we look at the cold, we can, for instance, increase our metabolic rate, as you can see here. We also change the perfusion in the skin. You see here the skin data. The details are now not that important, but with shivering, you can increase up to 5 times your metabolic rate. In this case, it's 3 times. But that's, of course, not so comfortable. But it's also possible, as you can see here, that prior to shivering, there's also non-shivering increase in metabolic rate. And that is rather comfortable. And we also found out which tissue is important, because with the shivering, it's the skeletal muscle. But with non-shivering increase in metabolic rate, it's the brown fat. And we found out that humans have quite a bit of brown fat, and that's a very healthy tissue. It keeps us warm in the cold without being uncomfortable, and it is linked to a better metabolic profile. So to make a long story, because we did a lot of studies on this, short, we found out that if you're regular exposed to mild cold, in this case 15 degrees Celsius, it's maybe not that what we want in our offices, but just as an example, we see that we get an increase in this healthy tissue, the brown fat. And we see that the glucose metabolism is much better. The insulin sensitivity increases. So that's good news for diabetes. And we see that also the muscle is involved in this. So it's really a systemic, whole body metabolic profile is increased. So we see a lot of parallel with exercise. We all know that exercise is healthy, but we also have enough evidence now that being exposed every now and then to cold is also good for your metabolic system. So then we shifted a couple of years ago and looked also at the heat exposure. And I don't have time to tell a lot about it, but here you see some of the results. And we see that if you are exposed regularly to heat, that it also positively influences your health. Your blood pressure and heart rate and glucose metabolism is positively affected, and you create better resilience to heat waves. So all in all, we believe that the dynamic profile, being exposed sometimes to the heat, sometimes to the cold, is healthy. And that poses a huge of interesting options for the built environment. That means that you don't need the strict fixed temperatures inside our buildings and offices that normally are achieved. No, you can just drift along with what happens outside and create a much healthier and energy and healthier environment, and saves a lot of energy in the built environment. This is to summarize what I just mentioned. You can have a look at it maybe later on in more detail. What's also important that if you get used to the heat or the cold, you see that the comfort also increases. In the beginning, you really have to get used to it, but gradually, within 10 days, you're used to sometimes being exposed to the heat and sometimes being exposed to the cold. So now this is some of the background that I just mentioned. I think it's important to realize that we are biological systems and that we are connected to our environment. So this is the team that worked in Mobistyle, and we did 3 different studies. We had a laboratory experiment in the chambers that I just showed to you. And we tested the idea of a dynamic environment in real-life living labs, the Keske office and the Huiger Brightland office. So first, I'd like to show you some of the results of the lab study. This is the profile we compared. So we had a fixed 21 degrees Celsius, and we had here the dynamic profile in the course of the day going up and down. We had fixed exercise in red. So to keep the person to do something, they had exercise here, and they had to just have desk work in the chamber. And we had questionnaires, we had some measurements. I'll show you here, I think, yes. So we measured the body composition, we measured energy expenditure, physical activity, heart rate, skin temperature, core temperature, and we had questionnaires about their thermal comfort. And I'd like to share with you some of the results we found. These are the subjects. They were young adults, normal weight. We also did in other experiments with other groups, but this is what I show you now. And here are one of the results. First of all, what's interesting to see is that in the fixed condition, you see the fixed condition, and this is the mean skin temperature. Sorry, this is the ambient temperature of the fixed condition. And here you see the skin temperature, and you see it deviates a little bit, but not that much. But if you now have the dynamic profile, so we had for each subject, we had both of the conditions. So here, if you have here the dynamic profile, you see this is the temperature in the rooms. And here you see the skin temperature, the average of all the subjects. And you see the skin temperature really follows the ambient temperature. That means that there is different perfusion in the skin and that the cardiovascular system is working. So yes, it works. And here you see the energy expenditure. We had a significant higher energy expenditure in the morning, and especially at this time point, which was also accompanied by an increase in physical activity. So somehow in the cooler morning, people were a little more active and expended a bit more energy in the drifting condition. Very interesting was that the thermal sensation really follows the room temperature. You can imagine that people, when it's cold, they feel colder, so slightly cool in the morning, for instance, here. But very interestingly, we see the thermal comfort was all within the acceptable range, from just comfortable to comfortable. And even in the drifting condition, in midday, you see an increased comfort compared to a fixed environmental temperature. So thermal comfort was really maintained in both conditions, so also in the dynamic condition. So in general, we can say, yes, there is a slight increase in metabolism in the drifting conditions, and that in general, the temperature ramp is voted as comfortable. So that really gives the potential of the dynamic temperature to increase our metabolic health and without compromising the comfort. So yes, the concept really seems to work. So we tested that in two conditions. Here you see the Brightlands office, and this is the Huygen office. So if we first go to Keske, sorry, I mix up. This is the Keske office, and this is the Huygen Brightlands office. Sorry for that. So we go here to the Keske community. These are generally younger adults. And they are living in an office environment. Here you see the plan of the office. And we really wanted to evaluate whether such a dynamic or drifting ambient temperature can be achieved and how it is experienced. And we again compared the drifting with the fixed temperature. So they were exposed for 1 week with the fixed and 1 week with the drifting temperature. Here's some impressions inside. You see young people sitting on the desk, working mainly with computers, and we installed 3 Daikin units and made them accustomed them to our needs of a drifting temperature. We could really control them carefully. So we measured again the same parameters here. I'm not going to repeat them all. You can later have a look if you want, but approximately the same as we did in the lab conditions. So here you see some of the results. Sorry, there's no legend here, I see. So we see here the indoor temperature during fixed in October 2018. So we had 2 measurements periods, and we had December 2019. And again, the fixed temperature. And the drifting temperature, you see here, going up, going down. So the drift was well achieved. Then we get some of the results. Here we see the skin temperature. I plotted here an individual because it's interesting to see that during fixed, the skin temperature is also rather fixed. And during the dynamic condition, you see the skin temperature follows the environmental condition. On average, this was hardly not significant, which surprised us. We expected a bit different. We don't know yet why this is. here you see the heart rate and physical activity that we could measure with ambient recordings, and they were not really significantly different between the two conditions. And I think the most interesting part is here that we see that the comfort is achieved in both conditions in general. So from just comfortable to comfortable, on average, it's within that limit, both the fixed, the static, it's called here static, and dynamic conditions, which shows that even in a real life living lab conditions, people really experience it as comfortable. Although there are always some individuals that indeed sometimes rate differently. So the conclusion from this small real life living lab study, I mean small, it were not with that many people, but still interesting that the temperature manipulation, we could accomplish that. The body temperature follows the drift, but not as you saw in all the subjects. And the thermal comfort is achieved in both conditions. We did also a test in the Huyghe Brightlands office with, in fact, the same study objective as we had in the Keske, although they also used another control system and subject information system that will be shown tomorrow by Loes Visser. But here I just show how people respond to the dynamic condition. Here you see again the static condition, the fixed condition, and here's the temperature of the dynamic condition. And the dynamic condition in this case was the range was a bit less than in the Keske. It's only a few degrees variation. But nevertheless, we see a skin temperature that more or less follows the temperature. I think I skipped this. This is the most important result, the comfort and sensation. And again, we see that it's rated. Comfort ratings are not significantly different between the static and the dynamic conditions. So again, we can say that it's really acceptable to have a dynamic conditions. And that's the main use, I think, I'll go to this one, that's the main use from these studies, that the moderate temperature drift does not lead to thermal discomfort, and that the lab studies reveal a significant increase in metabolism and physical activity. So yes, there is a metabolic challenge. The skin temperatures follow the drifting temperature conditions, so there is a cardiovascular challenge. So that really shows the potential of a dynamic indoor environment for our health, but also a potential for saving the energy metabolism. We're currently doing the last calculations on that, and that will be shown in the final report. So with that, I'd like to thank you for your attention, and I'm happy to answer some questions. Thank you.
Thank you all for your presentations. So we can start the Q&A. Please feel free to ask more questions during this time. So let's go with the first question, which is for Christina. During the presentation, we saw some key performance indicators referred to a specific area, such as energy, indoor environmental quality. Did you develop also multi-domains KPIs during Mobistyle project, linking together different areas?
Yes, so thank you for the questions. Yes, because as I highlight in the first slide of the presentation, and also as Dan highlight the fact that the approach of a Mobistyle project is a multidisciplinary approach. And an interesting thing is the fact that we have three research areas, energy, indoor environmental quality, and health and well-being. And we also try to put together these three areas because we have a single domain, we can say KPI, but we have also multi-domain KPI that try to combine these different areas. And of course, we have to develop this KPI also in function of the data, the availability of the data for the different demo cases. So it is possible also to do more, but of course, the availability of data is a constraint of the analysis. For example, we have the carbon intensity of consumption, that is a KPI that puts together the consumption and so the energy fields and the CO2 emission. That is a parameter that we can also relate to health and well-being. Or we have the energy performance weighted on the thermal discomfort. So putting together, for example, energy fields and indoor environmental quality and health and well-being altogether. This is just 2 examples, but we have developed also other multi-domain KPIs.
Thank you. Let's go on with the second question, which is for Wouter. Was the office building mechanically ventilated? The office referring to is the Huygens study.
Sorry, your question is
Was the office building mechanically ventilated?
Yes,
in
indeed.
The case of the Huygens study?
Yes, indeed. So an important thing is that during these experiments, the building did not really save energy. In the end, it should be applied, this dynamic condition, in buildings that can have natural ventilation mainly. I think that's one of the things. And if it's really not the case, then you should have a look at what is most feasible for the building you will use the dynamic system. So it depends a little bit on the building. If you're going to force against it, then it won't save energy, of course. Like for instance, if you have concrete, a lot of concrete with a lot of energy storage inside, it may be difficult to achieve a sound dynamic profile. So with natural ventilation, that's the best. Is that an answer?
Yeah, totally. So let's stay with you actually. People differ in their thermal comfort range. How do you deal with individual wishes?
Oh yeah, good question. Yes, there's an interesting thing about this dynamic profile, and that is how you anticipate on what's coming. So if you, for instance, with the dynamic profile start in a cool environment, indoor environment, then some people may like it, but those people who do not like it, they feel that it is getting warmer, so they anticipate better conditions and thereby already feel better. If you're a bit in the cool environment and you feel it's getting warmer, you feel better. So that is one thing. Another thing that can be done, and we are currently investigating that, is to combine this dynamic profile with some personalized heat and cooling devices on your desk. So then you can, for those people who are really too cold, for instance, in the early morning, they can have some additional options to get a better comfort. That may cost some extra energy, but all in all, if you don't have to have a fixed temperature in a complete office, in the end, you can still have energy savings, I think. Thank you.
And is there a link between temperature and productivity?
Good questions. We don't know. We are currently investigating that. There are indications that indeed, yes, in a cooler environment, your concentration may be better, your alertness may be better. Although there are differences in gender, there's at least one study that shows that women do better in a slightly warmer environment than men. So that's really a very interesting topic, and will get more attention in the very near future. But yes, it can affect your alertness for sure.
Thank you. So this is a more general question. Who is your target group when it comes to customers and targeted market?
Maybe I will answer or start answering from the side of coordinator that we were looking with whom to engage, and as I mentioned at the beginning, we had different demonstration sites. So what we see is that it could be really attractive solution for housing association and real estate owners, especially in the Dutch case. We saw that there is also for commercial buildings and the different CEOs to target. So to offer the healthy buildings and healthy environment for their occupants, their employees, and then service and energy providers. And also tomorrow when we are going to be presenting the ICT solutions, we're going to show why some of our solutions are also interesting for third-party developers and different manufacturers, and again, data providers.
Thank you. Also, what are the main outcomes and the main benefits of such a multidisciplinary approach?
Maybe it would be interesting to hear our speakers to say what do they see as main outcome of their disciplines.
Okay, may I answer on to this question?
Go ahead. Yes, please.
Yeah. So as I said in my presentation, I think it's time to move beyond this multi and interdisciplinary approach and start thinking more transdisciplinarily. So it means actually that we learn to collaborate, respect each other's methods, and start speaking the same language, as I said before. Because as philosopher Ludwig Wittgenstein said, the borders of my language are the borders of my world. And in this way, if we learn methods and language of other fields, we actually broaden our own world, also methodologically. And here in the Mobistyle project, for example, we brought together two completely different worlds. At least we see them in this way. For example, the quantitative and qualitative world. And at the beginning of the project, when we started more than 4 years ago actually, in 2016, we had quite some difficulties on our side, on anthropological side, to explain that this sample of people that will be involved in the project will be relatively small. It's a couple of dozen of people in different European countries. And I remember at our first consortium meeting when I said we will go really in-depth, do really in-depth study with approximately 35 people. The more quantitative scientists and researchers were a bit shocked, I think. Like they thought like 35? I mean, do you mean 35 million? No, 35. Wow, really? Because on the other side, so on the quantitative side, there is an impression that you need the big data to understand the people, the habits, the practices. On our side, for example, we think you have to go really in depth to understand each individual as much as possible. And then I try to explain that anthropology works in a way as quantum physics of social sciences. So we have to study each particle really into details to understand it completely. And then we started to collaborate, discuss, and the main point was we have to combine the approaches. The answer is not given only by anthropology or only by medical doctors or only by psychology or only by engineering. No, we have to combine the approaches and bring together the big data, so something that we can get with the quantitative science, and what we call thick data. So something that we can get by using the anthropological approaches, by talking to people, living with them, trying to understand them. And for me, this is one of the biggest results of the Mobistyle project. We started to talk to each other, we started to collaborate, and even I started to understand those acronyms such as KPI, IEQ, and so on. So for me, it also opened the world a little bit.
Thank you. Someone else would like to add something, or let's move on?
Well, I could say something. I like, as I fully agree with Dan, that the link between the different disciplines is very interesting. And what I learned from the engineering engineers is more about the buildings. And I think very interesting that in the end, we can combine our models. We have the human model, the heat production, heat loss, and we can link that to the built environment and the heat in the building. And so this is just one example. There's more in Mobistyle, of course, and I fully agree with Ben that also the psychology is also very interesting. But to link the models is also a great achievement, I think, with the collaboration. Thank you.
And
Thank you.
Maybe if I may add to what Wouter said, I think the only way to go in the future is to collaborate. We cannot find the solutions for these planet-centered models, whatever they will develop or produce, by any individual field. So we have to combine biology, anthropology, engineering, and I think this is actually the future of the European projects. Without transdisciplinarity, there will be no research and development projects anymore. So, and I think it's really emphasized in the call, or in this draft of the call for Horizon Europe, so the new perspective of research and development of the European Union.
Yeah.
Indeed. If I also may add, from the perspective from our ICT partners who are not today here as panelists, but will be presenting tomorrow, that a lot of those are also really triggered to in their for their business opportunities to now be applying this people-centered approach when developing new ICT solutions, especially Holonix partner who developed the dashboard really see the added value of this people-centered approach within the ICT development, and them as a long-respected ICT firm, very successful in Italy. They are now seeing how can they do a step further to step in comparison to other ICT developers with this integration of the people-centered approach within their business model. So it's also within the ICT partners that are seeing this need to integrate people-centered approach in the ICT development. And I think this is one of the big Mobistyle achievements that also really hardcore ICT and IT people see the added value and know that their solutions can penetrate better the market, because people will use those solutions, people will understand what they tend for, and not just for engineers and designers.
Yeah, and at the end of the day, it's actually much cheaper for the industry, for the business side, if they do these two first steps. So the identification and analysis of the people, it's actually very cheap in comparison to all the marketing that you have to do if you make some stupid, useless products, bullshit products that nobody will use and will just make lives of people miserable. So we actually have to do these two first steps, so identification, analysis, and ask people what do they need, how can we improve their lives. Otherwise we get products that are stuck at our home. We have at our homes up to 200,000 different objects. So we're just stuffed, our homes are stuffed with products and we don't know what to do with them. So in this way, with this approach, you get the more meaningful products. It can be also digital products, of course, apps. So our lives have become really appified. So we get apps for everything. But which of those apps are meaningful for our life? Which make it better? And if we utilize this kind of approach, I think we make this move also to more sustainable future. because we get less products, but those products are more meaningful and desirable also by the people.
Thank you for this brief debate. And as we have a very short time, I would ask one last question very briefly, if you can answer very briefly. How will results further be used after the project duration?
Oh, I think it's difficult to answer it quickly because I believe that each partner is going with a bit different exploitation path. And I think for universities, they will implement those results in their new knowledge, within the new courses or PhD positions, etc. Then the ICT partners are going to integrate or are going to have those, what I mentioned, we are going to be going with the 4 different ICT tools on the market, especially 3 ICT partners, demo consultants, Holonix, and Huygen will go with the ICT tools to the market, and Tauron will upgrade their current service to their energy clients with some of the Mobistyle results. So I think it's going to be very dispersed. But yeah, if any of the speakers today here want to say how they are planning to go further or what they will use from Mobistyle.
Well, first of all, I learned a lot about this dynamic profile and also the application of it. So I would really like to continue working with engineers and getting more exact information on the application of the dynamic profile. And the other thing is that it's extremely important also to see how people, the productivity of people and well-being of people in offices and dwellings, etc. Because that's really very important for the motivation of new systems. Thank you.
Okay, so thank you again for these presentations, and thank you for all the people who attended, and I hope to see you tomorrow for the second session of this webinar. Thank you.
Thank you.
Thank you.
Thank
Have
you.
a good day.
Bye.
Thank you.
Bye-bye.
Bye-bye.